spots on. Yeah.
With the exercise, you probably take
I'll use mine. So you can, if you want to, you can also take it off. Okay, so welcome back after fall break. I hope everybody had some time to relax and is now eager to go back into the classes. So today we'll be talking about views, what we can do with views, how we can partition them and so on. But first, Sean will do a little exercise with the design activity framework. Again, Sean is looking for groups. He has a couple of volunteer groups already, but he's looking for groups to supervise or to help out with the project, so please volunteer if you're at all interested in this. A couple of organizational points. Today, right after class, there is going to be the homework lab for homework 5, so that you will get an introduction to the homework. On Friday, there's your project information view, so here you should submit the names and some information about your team members, the name of your project, and the link to your GitHub repository that you will use as a group to work on your project. On Saturday then is the homework due. On Monday, your project proposal is due. So you should work on your project proposal by then. You should have worked on that already, I hope. But anyways, like there's a couple of days left. Then next Tuesday will be peer feedback sessions here in class. Carolina and I will both be gone next week at the visualization conference. So the peer feedback session will be run by the other 2 TAs. And so the idea here is really that you come in as a group and talk to the other teams, pitch them your project, give them feedback, take notes, and then do the other way around. So like you get feedback and you give feedback about your project. So you should be prepared for that, and you should have it fresh in your mind, given that you just handed in your project proposal. And the next Thursday, class is going to be cancelled since none of us is going to be here, and then we'll meet again the week after. And so, yeah?
For Friday's deadline, do we have to have a data set?
You have to have a project name.
Just a name, but you don't have to.
But if you don't have a data set, it's going to be hard to, like you should have an idea, a very specific idea of where you can get your data. And you have to have the data set kind of figured out on Monday. So I would recommend that you have a very good idea of what your data is going to be like by Friday. Any other questions about this?
The GitHub link, if we're doing something that's like proprietary, do we need to have that?
Yeah, there is instructions on the website for that. You create a private GitHub repository. You should have, if you follow the instructions in number 0, you should have private repositories. And then you add the user, which is called dataviz-ta. That's a user that we, the TAs and me, share, and so we can access your code. Any other questions? I'll probably be talking a little bit more on Thursday about the project, proposal. But yeah, today this is it. And a note on the midterms. Like since I'm going on to a conference next week, and this week is also terrible, I haven't started grading. And so that means that you won't get the midterms back for a while. I'm sorry about that. I usually don't like to do that, but it just doesn't work out this week, this time. Okay, so Sean, you want to get started?
Okay, thank you very much. So I'm just going to go back and do a quick recap of designing visualizations. I gave the lecture 2 weeks ago now. And so when we chatted about how you design visualizations, again, design is this process of creating something new to solve a problem. Whether it's a new visualization, a new system that combines visualizations, maybe it has multiple views that you guys will chat a little bit about today. And part of this process is finding the users that you would consider, that you need for the system, that would want to use it, what tasks they need to use, and then get and understand some of their data. So you guys are doing some of this process now as you work towards building this project proposal. And then we talked about the nested model as a way to capture some of these decisions that you make during this design process. And then also this design activity framework that I've come up with that can help guide you through this sort of problem-driven visualization design process. And so for this design activity framework, there's this concept of a design activity, which sort of just is collectively working towards generating some artifact. So we had these 4 main activities. Understand was about creating these design requirements, things that you might, design opportunities you could use to build your system to tackle, like tasks. Or whether it's constraints that might limit the system, things that you should consider that maybe you can only handle so much data in a web browser. Or other things that might be sort of considerations for the design, whether it's like, avoiding the rainbow color map, or other things that maybe you can fudge a little bit depending on the user's needs. And then we have Ideate for creating ideas, Make for building prototypes, and then Deploy for fully building out a visualization system. And so for this, we had these design activity worksheets that we have crafted to help guide basically through this process, guide you through this process with guided methods. And so here's an example of the Understand worksheet on here, sort of filled out. And I'm going to be creating a full example for the cybersecurity project that I walked you guys through in my last lecture. And that'll be within sort of this worksheet mindset, so you can kind of see how it sort of varies over time, the types of artifacts you can expect, how we sort of expect these worksheets to be filled out. So we'll send a lot of these details out via Canvas. And so for that cybersecurity project, one thing we did is we go through, say, this Understand worksheet. One of the boxes is to identify the challenge and then the types of users that you want to work with. So in my case, the challenge we first tried to go at when we were starting out this project was we wanted to build this cybersecurity dashboard for communicating data. And we had different types of users. Some were cyber analysts, and others were people, researchers who studied those analysts. And we didn't expand to more users, but as I mentioned with these personas and things, we eventually did. But that was later in the project. So it's okay to come back and revisit, say, this Understand worksheet or other worksheets over time as your project focus might shift a little bit. And then the second box on this worksheet is to find the questions and the tasks that you want to try and achieve. So some of these questions could be like, what parts of communication are tricky or slow for analysts currently? And what data sets are most important for this process? And then what kinds of patterns that analysts can find or cannot easily find with their data, so we can maybe help them first achieve what they can do, but then also maybe achieve a little bit more. And then later, we also had this question that came up, like what users do they need to communicate with? Things like the managers that we hadn't considered just yet. So again, coming back and revisiting what you filled out can be useful to find new questions and new tasks. This third box is about sort of checking with the users that you have access to, or that maybe you can research, talk with, observe with, or explore the data set that you have access to. And all this is about trying to find and understand both the users and the data that they're trying to work with. So for my project, again, these users, they use like reports data, but they don't always map back to other data sets very well. And then the data set side of it too, they had these reports that are, again, a separate data source. And then they also used often these IDS alerts with some of the users. And those are also 2 very common data sources that we wanted to think about combining. And so then this brings us to sort of these design requirements. We wanted to brainstorm what ones are possible. And things like making understandable data visualizations, things that people can know right off the bat what they need, versus maybe scalable visualizations that handle lots of data. Or maybe having multiple data sets that you show at once, whether in one view or multiple views. And then linking those data sets together to find what commonalities are there. And then lastly, simplifying aspects of the data, because it was a very rich multi-dimensional data set, and we couldn't show all of the data at once. And so these design requirements are something that you want to show and achieve with this final visualization. And in here, what I have bolded here are certain we evaluated some of these design requirements to tackle some of these more specifically early on. Finding like understandable data set or visualizations and linking those together and simplifying the data. And that's sort of this final step of the worksheet, the box 5, is to evaluate those components. Whatever you've generated is to try and find which ones are the most potential for maybe making the project better. And usually I would suggest creating at least 7 to 10 of these. This is just a snapshot of some, so that way you can sort of filter down. And if you don't have enough or you have too many, it might be good to revisit this worksheet to maybe find the better challenge or find the better tasks or users you want to focus on. Are there any questions on this sort of project that I've talked about? All right, so we're going to move forward with a redesign exercise. So here we're going to be looking at real-world visualization and trying to redesign it by looking at what types of users should we consider, what types of tasks are important. It's also important for you guys to take a look at and understand what's going on in the visualization. And then there's multiple views here as well, so we'll talk a little bit more about that later in the class. And so I'm going to be passing out some worksheets to start, but before we get into that, I just want you to find a partner. We need someone who has access to be able to pull up these, so try and find the right partner there, and browse to this website, and then try and understand all of the views and discuss them with the partner. So we're going to take like 3 to 5 minutes, just understand it. If you have questions about what you're doing, just raise your hand. We'll be passing out some worksheets in the meantime, so you'll have those for the next part of the exercise.
Yeah.
So this was just, we can pass that out as well, and then I can just pass out these two. So that's just the reference. Yeah, from there. Did you need any more? You only got one? You should have 3 sheets.
I'm the dear.
Oh, I'm sorry. Did you want one? No. Okay, sorry.
I just clicked one because it
All right, just take the next minute or two to wrap up looking at this example with your partners. And then we'll get to the worksheets. You don't need to worry about reading too much in detail, but some of that's just for your reference.
Oh, okay. So, like, we're counting averages.
Oh.
Oh, we didn't go over that. What you taught, right?
All right, if you could wrap up those thoughts right now with your partner.
Maybe you can briefly go through the website and you can real quick.
There's one that points up. This is on okay.
you click on
Oh.
All right, does anyone have any questions about the visualization or about sort of this page that they have here? I'm going to walk through some of the views just to kind of so we can recap, make sure everyone's on the same page of what we're looking at. So as you navigate to this website, it will first ask for your location, or you can type in one, or it'll just pull up some. And then it'll, from this map view, show like a snapshot of a selected region. In this case, Utah, it's recognized where we are. And then it has sort of a summary view of these 11 different factors. And so these 11 factors are part of this measure what they're calling well-being, the OECD, and there might be some more details on this website, and the data set's available if you want to take a look. But they just sort of have a very summary view, and if you hover over, you can find out a little bit more, and you can click on it as well to find a snapshot of what each of those are for each of those different factors. Things like health, safety, civic engagement, education, a lot of different things that might improve, say, the well-being of a nation. And for these, you can also see similar regions listed down below. It's sort of part of all this top view is what I've called this here. They sort of allow you to select and find information about region. And then below, again, well-being in detail. So this gives you a breakdown of a lot more of those factors, comparisons, and different things in a different view. Does anyone have questions about any of this, or does it all make sense? Okay. So for now, what we're going to do as part of this exercise is in your partnerships, you're going to split up. So each of you is going to take either this bottom set of views that are these detail views down at the bottom, or the top view, which is sort of about this map view as well as a summary view and some of this comparison. So decide between the two of you which one you guys want to focus on. So each of you will pick one. And then from there, you're going to focus on just one of the worksheets. So everyone should have 3 sheets that we've handed out. If you don't, just raise your hand after this and we'll make sure you get it. And so one of those sheets is sort of a double-sided overview of the design activity framework. And this just has information about how you fill out these worksheets, about what the design activity framework is about, and another side is about sketching. And so feel free to peruse this if you have time, or in the future if you want to find out more. We'll link these online so it'll be easier to navigate to some of the URLs and you can just click on it. And then the other 2 handouts that you should have gotten is the Understand and the Ideate worksheet. So we're going to start with the Understand, the sort of quickly worksheet. So it just says Understand in the top left. And you guys are going to split apart in your pair, and again, either focus on the top or the bottom view, figure out who's doing what. And you're going to fill out boxes 1, 2, and 4. And so 1, 2, and 4 are about 1, 2, and 4 are about identifying the challenge in the users, finding questions and tasks that they would have, and then brainstorming design requirements. And we are going to suggest at least 1 to 3 design requirements, but feel free to come up with more. And so think about your view and what, if you were to redesign those views, what would you want to achieve? Or what did the original designer want to achieve there? And feel free to think outside the box. Is there data that maybe they aren't showing or that you could show as well? So feel free to think about other things you could incorporate. And if you need more space, the back should be empty, and we have plenty of extra pieces of paper and utensils. So just again, raise your hand if you need anything or have questions. So just feel free to work on your own on this Understand activity, and we'll come back in like, say, 5-10 minutes whenever people are getting wrapped up. Yeah. If you need utensils, we have problems as well. Okay, so the affected by is referring to the might be some people who might be worried about all of it together. So think of those types of people. But it sometimes helps to figure out, you know, a challenge. Problem. Why would they go this? What are they hoping to get out of this? Or when someone put this website together, what were they trying to get achieved? They designed it a certain way for a certain reason. So some of this worksheet is trying to pick apart something that's already set down as opposed to starting from square. Does that make sense? Or is it still kind of confusing? Yeah, I mean, it's totally valid to say everybody can be a potential user, but sometimes there might be certain aspects that we learn from certain types or certain things some people might try to achieve. Like I said, there's no one right or wrong answer. You could probably do this worksheet 20 times, there's 20 different things, and each one would be fine. You could even have everybody should be user for 20 sheets, but maybe each time the challenge is like you said, maybe it's about doing this. Maybe about looking at next. So you know, like, Alright, so I just want to check up to see how people are doing. Does anyone still need some more time to fill out those boxes? It's totally fine if you do, we aren't in a rush. Just raise your hand if you do. Alright, we have a few people that do, so we'll wait a little bit longer. And as you're working on this, just remember we're trying to think about the challenges that maybe different types of users might want to achieve. What is the audience of this web page, of this design? And then tasks people might want to fill out, or might want to do with this. And try to get design requirements again in that last box, number 4. You only have to fill out 1, 2, and 4. And these design requirements are something that you might want to show or have achieved by a user in your specific view. And if you finish early too, feel free to chat with your partner about what you guys looked at, what you wrote down on your worksheets, and adjust if you guys have comments or thoughts.
Sure.
Yeah.
Does anyone else still need some more time? Again, just raise your hand. Any more time? Anyone? All right, so the next part of the activity, everyone should also have one of these pink Ideate worksheets, and we'll be going through that next. Again, you'll just be working on your own to think about what you've just worked on. So in box number 4 here, you guys created some design requirements. And now we want you to take a look at the Ideate worksheet and select one of those design requirements in box number 1, and then come up with 2 ideas, so 2 new sketches. And if it helps, sketch what's already been done in the tool. Maybe that'll give you some inspiration, some ideas. But come up with 2 new ones. We handed out some extra pieces of paper, and if you need more, we have some, so just raise your hand. Yeah. Was there listening?
This says that Wyoming.
All right, just as a nudge, make sure that you're picking that design requirement. If you haven't by now, definitely do that. And definitely start working on that second idea, that second sketch. And try and go for something really different. Think of different layouts that you might have learned in the course, or different ways that you might show the data, even at the raw data level. What is a different way to think about it? Strips away like the details and just kind of highlights the different parts, what they are.
Yeah.
Sort of tips about what things are for, and you can this out for different
Yeah.
stuff like that. So
Yeah.
that should hopefully be another nice little addition, I think. So finish that. Try it out.
Yeah. It's a little, for redesign, it's interesting. Like, the sketching is good. The challenging users is, I guess, more interesting to let people back up.
Right, yeah. It's a little bit tricky, but I think it is still interesting to think about. Maybe that's me in the trenches. If I could just see a hand if you're still working on that second sketch, still need some more time. All right. So give you guys some more time. No problem.
I'd rather than run for beats because there's no overhead place.
I thought
So this one doesn't use the right place. There is some $10 each. No, it's just
Does anyone need some more time? Just raise your hand. I'm not seeing any hands, so is everyone's done then, I'm assuming? So feel free to wrap up those thoughts if you need to, but the next part of the exercise here is to get back with your partner. So we're thinking now you've done this generation of these artifacts, you've created some of these design requirements, found some rather, in this case this redesign project, and then we're going to now evaluate those. And you're going to walk through what you've just done with your partner. So look at those, the understand worksheets, and look at the ideas that you've come up with, those sketches, and then try and fill out box 5 on the Ideate worksheet with your partner. So first go through understand and what you found if you haven't yet, and then the Ideate worksheet. If you have questions, just raise your hand. Just remember to talk about why you picked these design requirements, and then why you picked some of those ideas that you did.
It's like one Sure. What do you want to talk about first? So,
wrap up some of those thoughts with your partners. You should take a look at it.
It's fine. It's exactly what I expected.
But I can still open it. There's a bunch of Did you learn something?
I think it's good to take time on that.
Right, yeah.
And like this specific thing in mind.
Yeah, having it grounded. Yeah, I think having my example has been helpful. All right, if you could just finish up those thoughts with your partner. All right, so I hope you guys have learned a little bit about the design process, about how you can use these worksheets. In this case, we looked back at a project, something that's already been done, trying to think about new ways to maybe adapt that. And so a lot of this was just really part for your learning for doing something, learning by doing. And that's really, I think, important when it comes to design. And I will walk through a sample solution so you can see a little bit more, but also talking with your partners, talking with other people is really important in design. It's really good to get some outside thought and get opinion maybe to help guide what you would do next. You might have thought up some new ideas with your partners, or maybe gotten, piggyback some thoughts that maybe you saw your partner had this really cool sketch, and maybe you'd want to do something with that. And so I would encourage you to do that with your own design, with these own final projects in the course. Talk with your partners in your group, talk to the TAs. You can even use them to help do this evaluation, this last box on each of the worksheets. And so sort of a quick sample solution that I whipped up. For this first box, identifying the challenge in the users, I selected the top views. It seems pretty simple, straightforward. We do like some region selection, and then there's an overview for that selected region. And so the challenge here that I identified was to convey and compare a complex, multidimensional view of the well-being or quality of life for a selected region of the world. So that map view is about selecting a region or selects one automatically, and then it gives you a snapshot of that. And then there's another part as well about finding maybe similar regions as well. And the types of users that we might care about or that might care about this page in particular could be like curious residents of an area. You might have looked up places you've lived or might be interested in living and find out what scored well or maybe not for that area. But it could also be things like concerned citizens or maybe politicians who maybe want to look for ways to improve a region's quality of life. Which things should they tackle? As well as maybe a sociologist to compare the well-being in different regions, maybe some that have like a lower socioeconomical status or higher ones to see how they fare and how that maybe shifts across the world. And then going on to the second box is to find the questions and the tasks that maybe users are trying to answer. Things like, what are the scores of my home region? Or how is my home region compared to the rest of the world? And these could adapt to other types of regions that you're interested in, not necessarily just the home region. And what is a good score or a bad score? Finding out information like that could be really interesting. What areas could be improved? And then maybe where could we look to improve it? Who can we look at for modeling behavior for these weaker areas? And some of these questions maybe weren't really addressed in the initial design, so that could maybe help you come up with new ways, new ideas. And then for box number 4, some design requirements that I've identified. There's like locate and find a home or a desired region. Another one is to simplify reading data values for the metrics more precisely. Distinguishing easily between the different metrics, we have 11 of them, and color can maybe be tricky in this case. And then compare data values across metrics and to other regions. Define and compare selected regions to similar ones, and a couple more. So I italicized ones that for these ones, like a map view worked really well, and it didn't seem like, and what they had done I thought was pretty decent. And there could be better ways, but having a map is pretty straightforward. People know how to read them. You could tweak that view a little bit, maybe optimize it, or find better ways to use it, or a search box could be useful. But for me, the key design requirement that I want to tackle was simplify reading data values for the metrics precisely. We know that when it comes to angle or when it comes to radius, those sorts of things, it's really tricky to do comparison. And that little radial chart that they had was kind of hard to be able to say, how is this length compared to this length? and what are the numbers. Now they did give the numbers, so that helps. So the idea that I quickly sketched up here was very similar to what they had before. We had like this map-based view and some similarity views at the bottom. And then I just kind of tweaked this layout here to just have a very simple bar chart. And just some, rather than multiple colors, just sort of like a rotating color map, and sort of have everything be aligned so it's maybe a little bit easier to read those 11 different factors, because you don't have to keep rotating your head around the chart. I can't read things sideways personally, but that's just me. And then I also gave an average. And this allows you to compare things on sort of a spatial scale really quickly. And then maybe if I tweak this some more, because I just sketched this up once, maybe add some white space and things so that it's a little clearer when one region doesn't overlap with another. So that was just a small sample of one sketch, but there's many other ideas you guys might have had. And again, part of that is just going through and generating these ideas is important, because you might find new things, find new ones, new things to explore. And so these design worksheets, we're going to send them out via Canvas, and we encourage groups to use them for your final projects, for these project proposals if you wish. And as you progress towards this project milestone, they'll really help you, I think, come up with new ideas. And evaluate those with your group members and with TAs. And along with that, too, the groups that I'm working with, we're also going to be using them more as like part of the process as I meet with groups and work with these worksheets through them and help you come up with more improvements. So I definitely want to work closely with the groups that I'm working with. And so remember that you can sign up with me to advise a group, otherwise they are assigned randomly. And it's first come, first served, email's there, you can contact me on Canvas, or just come bug me after class too if you want that. And remember, there's limited space. And so at that, I'm going to be turning it over for the rest of the lecture.
Okay, great. Thank you, Sean. Any more questions? Please remember, I think the best approach is that you just walk up to Sean today after the lecture if you're interested in working with him. And since he might also be able to help you already before the project proposal submission.
Yeah.
Okay, so today I wanted to talk about views. Views are really an important aspect of visualization. So for example, in your project, we explicitly ask you to build a multiple coordinated view system. So you have to have two views that interact in some way with each other. And so we'll look more formally at what we mean by views. The principle of multiple views is this idea of eyes over memory. Like the visualization essentially, it's things that make us smart. We can make explicit connections we don't have to remember. So for example, if I have to scroll through a timeline or to scroll through like a list, I have to manually move around and remember things. But if I show two aspects, two facets of the same data set, at the same time, I can look at it at the same time, make explicit comparisons, so I have this eyes over memory principle. And so we'll look at a couple of different ways of arranging and creating views, about shared encoding, about shared data, about shared navigation, and then we'll talk about partitioning for the rest of the lecture. So what are linked views? Linked views are multiple views that are simultaneously visible and linked together such that actions in one view affects the other. And so we've seen this before. There is a couple of different options. So first, the encoding can be the same or multiform. And so we'll use this term multiform a couple of times today. That means that we use different encodings for at least some shared data. And the data set can be completely shared, so I can show the same data with two different views. It could be a subset, like one data set could show all of the data, the other could only show a subset of the data, or it could not be shared at all. Then for highlighting, the question is to link or not to link, and for navigation is also whether the navigation is shared or not. So for navigation, for example, if I have like a map view with like a little tiny overview in where you see the whole world, if I want to share the navigation between those two, then we would have this shared navigation. So here's a very simple example of like a MATLAB plot with highlighting. So you can see, like when you highlight, when you brush one region, you can see where the corresponding points appear in all of the other plots. But you can also do this in a more sophisticated way. So here is a tool which is called Kshift, which is like a very nice exploratory data visualization tool where you can upload your own tables, where you can just like plug in a Google spreadsheet. And then this tool, essentially, all it does is it presents aggregate visualizations like histogram or bar charts. So this is about 5,000 companies in the United States. And these companies are in different sectors, like IT services, marketing, and so on. And so we can see there's 734 IT service companies, there's 453 marketing companies. And whenever I highlight one of those, you can see that they're dynamically like highlighted in all of these others. So I can see like IT services is roughly like evenly distributed with respect to growth, and is also roughly evenly distributed with years on the list. So by like if I look for high growth companies, we can see that it's a little hard to see, but advertising and marketing doesn't seem to be a high growth sector, but instead IT services seems to be quite good. And I can also in this case filter down on that, and now like everything is reordered. So these are multiple views. They show me different aspects of a data set, different attributes of a data set, and we can see these relationships based on linking. So like I mentioned this multiform word, what does multiform mean? It's different visual encodings are used between the views. This implies some degree of shared data. Either all of the data is shared or a subset of the data is shared for overview and detail view. So I have one representation that provides an overview, and then I have a second representation that is different that provides a detail for a subset. And the rationale of doing this is that single monolithic views have strong limits in the number of attributes that can be shown simultaneously. In your homework, this is like an example of a multiform view. So we have, in this case, we have two different, we have multiple views, but I'm looking, these two actually represent the same data. They just represent different aspects of it. They like emphasize different properties. So here, for example, we see like this is scaled by electoral votes, and therefore the electoral votes are the prominent attribute, whereas here geographic location is the prominent attribute. And also, like you could also argue that since everything is the same size, like the balance of the states is the prominent attribute. So we have two different views. They show the same data, but they use different forms to represent the data. So when we talk about shared data, what we mean by that is that we show all data in its view, but with different encoding schemes. And the idea here is that different views support different tasks. For example, and we'll talk more about this, these kinds of network visualizations later, but just to give you an idea, you could represent a network as a matrix and as a node link diagram at the same time. And therefore kind of ideally balance the trade-offs between both of them. The matrices are great for visualizing edge attributes, for example. Node links, Venn diagrams are good for visualizing the topology of a network. And if you show both of them at the same time, you ideally, if you use synchronized highlighting, you could leverage the benefits of both of them. So you have same data, different idioms or different visual encodings. That's what's multiform. Here's another technique that I recently published. This is a tool for network analysis. So here there's two different views. This is based on, this is a co-author network, and so we run a query from this person Hans-Peter Pfister to this other person Ben Schneiderman, and we try to find all of these, all of the connections, whether they have the direct connections, which they don't in this case, or which are the connections. You have probably heard of this either as Erdős numbers or the Kevin Bacon numbers. This is the kind of thing here that we look at here. And so here we have a list of paths that connect those people. So this here shows a list of paths. And here we see the same data, but shown as the topology overview. And so what we can, what the benefit here is, here we can see the structure, we can see which are the critical nodes that connect this network. here we can see the individual path better, and we can actually use the space down here to visualize attribute of this node. So we kind of make use of this multiform property to leverage benefits of them both. And of course this is linked, so if I highlight this path here, you can see that this path is also highlighted in this other view. Okay, so overview in detail is another important multiple view technique, where one view shows an often summarized view of information about the entire data set, while additional views show more detailed information about a subset of the data. And so why would we do this? Well, for large and complex data, a single view of the entire data set typically cannot capture finer details. And so here is an example of a time series data set. This is like the overall time series, and this is pretty aggregated, so we don't see every detail. And then here the blue region is highlighted and then enlarged here. And within this blue region here, the red area is highlighted, and we can see even more details about the red area. And you can see that this is rescaled, so we can see details about the interaction here, which are simply not really very evident in this top view here. So we have this like different resolutions, multiple views that show the same data, use the same encoding, but simply use a different subset of the data. So overview in detail. Another example here is MISV. It's one of the visualization techniques that Mariah Maya developed. So you can see that we have, like, this is our chromosomes of one species, and out here are chromosomes of another species. The idea here is to visualize symphony, so how the genes are preserved across species. But the point here is that this chromosome here is selected. So we have like an overview of, like, this is the overview view here. So like the chromosome is in this ring in this order. And then for that we have, for this particular chromosome, we have a detailed view here. It shows us more information. That shows us essentially like for the same region we have more information. And then we have also this explicit comparison in the third view here between the selected chromosome and one other chromosome. So another overview in detail example. And so here is another one, an overview in detail example where we use the same data and the same visual encoding, just different scales. So these are clustered heat maps. So in this case we have 4 clusters, and this heat map, this larger heat map here, is simply an enlarged version of this here. And so you could argue, well, this isn't very important for this case, but in this case where we show like a network juxtaposed with experimental data, these little tiny networks are basically unreadable. So you need this enlarged version, and you still want to have this context. Okay, so we already talked briefly about small multiples. The small multiples is the idea that each view uses the same visual encoding, but shows a different subset of the data. And so the rationale for this is to quickly be able to compare different parts of a data set relying on eyes instead of memory. So here is a good example of that. This is a network visualization. This is a biological network, and then color-coded on top of these networks are attributes for these nodes. How active are these genes? And instead of like trying to encode all of the information in one node, we see the same network, in this case, 6 times, and we can try to make comparisons. So we can see, for example, that here there's no value for this node, or we can see that here there is like a cluster of mostly red ones, whereas here there is one green one. So there is a nice video that explains this in a little bit more detail.
Collected for each node in the graph. Each experimental condition is mapped to a small multiple view and an axis in the parallel coordinates view. The values associated with a node map to an intersection point on the axis and a color coding in the small multiples view. The size and number of columns in the small multiples view is adjustable. The user can reorder conditions by dragging axes or the small multiple views. The reordering is linked between views. We reorder the values to place the time series in order and each control LPS condition beside the treatment LL37 condition. Looking at the small multiples, the LL37 treatment has the largest effect at hour 4. We compute a direct calculated difference in the main view and see that most genes are colored orange, indicating repression, particularly amongst the inflammation-causing cytokines and chemokines.
So this is an interesting example. So we have small multiples to show the raw data, and then we have this larger view, which is also a multiple that shows a derived data set. And also the Stratamax tool that I talked about earlier uses small multiples. In this case, not in any of those detailed views, but here in the overview. So this gives you like a rough idea of, again, a biological network, a very similar use case. Here you can, for example, see this is like the cell order here, and here you can see that this is downregulated, which is indicated by blue in this group, whereas in this group here it's upregulated. So you could say, okay, this looks interesting, and then I pop this out, and then I have this overview plus detailed view, and now I can inspect that in detail. Okay, so next I would like to talk a little bit about partitioning. Partitioning is really a very powerful technique. It's an action that separates the data set into groups. And so you have here a couple of design choices. How do you divide the data up between views? For example, give them a hierarchy of attributes. How many splits do you want to make? The order of splits. How many views do you want to have, which is usually data-driven. And partitioning attributes are typically categorical, but it can also be based on bins, for example. So here is two different examples for the same data. This is population data for a couple of states in the US. And then we have also these groups, these age groups, under 5 years, 5 to 13 years, and so on, and they are color-coded. So like in the first case, we have it partitioned the state and then align it by these groups. So we get this impression of like how is the age distributed across the state. And here we are partitioning by both age and by state. So like here the state partitioning, and then here we have the age partitioning under 5-year-olds, the 5 to 13-year-olds, and so on. So in this case we have both partitionings. In this case, of course, it is a little like since we use less space for the marks, they're a little bit harder to read on the right, but then comparisons here are easy to make either row-wise, so where are the most young kids, or column-wise, so how is the age distributed in one particular state. Then I could also partition by category. We'll be using this data set as for an example a little bit later too. This is this iris data set, which is about sepal length and petal length and petal width and sepal width. And so these are 3 different plant species here, or 3 different plant species here, and we could plot all of this in one scatter plot, but we can also simply divide it by the category and see that this nice cluster separation here. One very sophisticated way of doing these partitions is what's called trellis plots. Trellis plots, they divide data into multiple panels. So here we have panel variables, which are attributes encoded in individual views. We have partitioning variables. The partition attributes assigned to columns, rows, and pages. And then you could also do some kind of ordering, some smart ordering. So let me give you this specific example here. The data here are barley yields in 2 years across multiple farms for multiple barley strains. So here, this column is 1931. This column here is 1932. Then here we have one farm. Here we have a second farm. Here's the third farm, and so on. So we have partitioned by year and then by farm. And then what is in these rows is different barley types. So we have Wisconsin number 38, velvet, and so on. And so we can see these trends and we can try to make comparisons. And this is like nicely split up, and we can see that the Morris Ranch, for example, here, it has not had great yield except for this Trebi strain, whereas it had better yield in 1932. So which is kind of like not quite the same for many of these other plots. And so this is like a very extreme example of partitioning. You could also like not partition the year, for example, which in my personal opinion even is a little bit more informative. So here we are coding 9032 by pink and 9031 by blue. And so we can see on each of these lines, we can see these exact relationships. And here we can easily spot for the Crookston ranch, for example, 1931 was a much better year, whereas for the Morris ranch, 1932 was a much better year. And so what you could do here is, like, the ordering here, of course, plays also an important role. So you could order both within each of these views, then you could order the year, and then you could order the views themselves. So you could use aggregates to order them. The only thing that you should never do is like use one ordering for like independent orderings for each of these views. So this ordering needs to be constant across the views. Otherwise, it's just going to be very confusing. For partitioning, there is also like a way to use partitioning recursively. And so there's one great example that I want to show. And so the idea of recursive subdivision is that you take multiple attributes and split up a data set based on these multiple attributes. And there's one tool that does this very flexibly, and I'll show this a little bit later. And the fundamental technique for this is a tree map. A tree map is a space-filling layout for hierarchies. So think of your file system on your computer, right? You have one top-level root folder, and then you have, for example, your folder for all your schoolwork, and in your schoolwork folder you have some videos from this class, which take a lot of space. And so these videos would be the leaves. And these videos would then get large rectangles in this tree map. So this would be like the video, this would be your folder for this class, and this would be the folder for all of your schoolwork, for example. Here is, this particular example is stock values. So the market capitalization of the companies. So here Google, for example, is given by the size of this rectangle. The color shows the change, the recent change. So Google had an okay day, it's in the green. Whereas other companies here had a bad day, they're in the red. And they're nested, they're partitioned hierarchically based on sectors. So Google is in the technology sector. And so this is like one natural way in this case, but we could also do this subdivision artificially. And so there's this tool which is called Hive that allows you to take any of these data, like any data attribute, and partition it dynamically. So what you see here is a map of the London property market. You have a couple of things like property sales across years, across months, in various boroughs, in various quarters of the city, and then you also have house types. So here, this is partitioned first by house type, then by neighborhood, and then by sale types. You have encoded the average price in color and the number of sales in size. And so here you can easily compare between neighborhoods the different housing distribution, and within neighborhoods similar prices. You could also completely change this partitioning. So here we're partitioning first by neighborhood location, then by neighborhood, then by house type, then by sale time, we're sorting by sale time, and then year, and then sorting by sale time month. And encoding average price in color, and the size is uniform for each sale. And so here you can clearly see that expensive neighborhoods are near the center of the city. And all of this is a lot more impressive.
This video is summarized in Survey's 2009 paper of the same name. It demonstrates how hierarchical layouts can be used to explore multivariate data through the reconfiguration, using London property transactions as an example. We run through all the figures in the paper using the notation we developed to describe their states, the operators we use to reconfigure their states, and show how it can help us address research questions. Property transactions in this view are conditioned using property type and the year of sale. Rectangles are sized by the number of sales and coloured by the average price. Almost half of all sales are flats. Since rectangles are ordered by size, temporal trends are difficult to detect. We will now reconfigure the layouts to arrange the years chronologically. This view more clearly shows the upward trend in average price. To increase the temporal granularity, we will add month to the hierarchy. We also recolour to reflect the number of sales. We call these calendar views. Years are arranged from left to right and months from top to bottom for each year. Purple is used to show the number of sales, which appear to vary seasonally. We expect there to be spatial variation in these data, So we will now insert London Borough into the base of the hierarchy and use orange to show average price again. There are marked differences in sales, shown through size, and price, shown through colour, between boroughs, but it's difficult to see how this varies spatially, as all the rectangles are ordered by size in the top left. We can see, however, that Wandsworth in the top left has the most sales, and the City of London has the least. The size order doesn't let us identify spatial patterns very easily, so we now rearrange the rectangles spatially and temporally. We can now detect some spatial patterns. For example, we can see that the highest average prices tend to be central and west of the centre, and sales of flats dominate centrally, but less so peripherally. Rectangles are small where there are low sales, making it difficult to see the detail. In the next view, we fix the size of rectangles to show each with equal prominence. The detail of property types can now be resolved more easily, even where sales are low. To study how much each borough differs from the average ratio of property type sales, we will hypothesize that all boroughs will have the average ratio of sales, establish this as a baseline, and then colour by the deviation of sales from this using a signed characteristic. This procedure can be used to test hypotheses. The diverging colour scheme shows blue for lower than the baseline and red for higher than the baseline, showing that flat sales dominate in the centre, but terraced and detached housing dominate in more peripheral areas. We will now remove property type from the hierarchy. These calendar views by borough show sales and average price by month and year. As such, monthly trends by year are emphasised. To investigate the trend over the whole period, we will order all 108 months chronologically from January 2000 in the top left to December 2008 in the bottom right. This shows a rise in average prices over the period and a fall at the end. We will now assume there is no seasonal variation in sales and colour by the deviation from this baseline. We will now do the same for average price. Brown shows higher than average prices towards the end of the year, within the year. This is consistent with our findings so far. Note the trend appears to be reversed in 2008. We will now consider different granularities of space, starting with boroughs. This is a rectangular cartogram of boroughs sized by the number of sales and coloured by the average price. We now add London Ward to the hierarchy to study patterns at different spatial granularities. Here we see that some boroughs have large spatial variation in price within them, and we can see the spatial patterns of these. We will now move these rectangles to their absolute geographical positions to demonstrate how this relative geographical view relates to absolute geographical space. The visual occlusion makes this view difficult to interpret, but it demonstrates the geographical distortion in the previous view. We will reconfigure this to a Gasner cartogram with boroughs sized by the number of sales, preserving the geographical shapes as much as possible.
Okay, so this is a very flexible technique to dynamically partition and code and so on, all within one simple tool. So this is a very powerful technique. So to conclude, let me briefly talk about layering. So here, up to now, we've always talked about dividing things up into multiple views, but of course you can also combine multiple things in one view. And there is the obvious examples, like it's very similar data, but you can also combine different data into one view. So the rationale here is that we can support a larger, more detailed view than using multiple views. However, we have this trade-off that it imposes constraints on the visual encoding choice. So we cannot layer everything on top of each other. And of course, it is also limited with respect to the layers. So one very simple example here is we have 3 different layers in a line chart. So we show simply 3 lines. And as long as you use the same scale, that is a very obvious and very simple example. Of course, this only scales so much. So here is an example of CPU utilization over time. First for only 2 processors, then for more processors in a compute cluster, and then as soon as I add more and more, the layering leads to overplotting it. So this is not very useful anymore. So here I would need to do something smarter if I still want to see anything. And then you could also combine this. So here we have partition and a layered graph. So here this is partitioned by rows and columns, and then this is then a row-wise layering, and here we have a column-wise layering. So we see these are temporal trends, and then here we have all of these combined in one small glyph layered on top of each other, and by allowing interaction, we can do this immediate comparison. So we can see this is a very homogeneous trend here, and we can still inspect all of these details in the individual views. So this is a rather powerful technique that you can use. Okay, and then I'll show this multiple coordinate view to the max video next time before I get started on filtering and aggregation. So see you on Thursday, and please talk to Sean if you want to have help from him with your project.